If you like this video, please subscribe, like, and go to training.mammothinteractive.com where we have tons of more videos just like this. In this lecture, we are introducing Unity visual scripting, how to code visually in Unity. So we are dragging and dropping blocks instead of coding with a coding language. So let's dive into Unity visual scripting, formerly known as Bolt. Visual scripting allows us to use graphical elements, which represent different programming elements like variables, functions, operators, events, and more topics that we'll get into in this course. So instead of having to code out with a coding language all of our different elements in the game, we can do so graphically. We can connect nodes that represent different elements together to create a logical flow. So instead of writing code line by line, you can build your code visually. So you're still using programming topics and programming elements, but you are building out the code visually. So visual scripting is a great place for beginners to learn how to code in a more friendly interface. With visual scripting, we can create logic for games or apps without writing any code. Instead, we use visual node-based graphs, where a node is a block on the graph, and each block represents an element like a number or a piece of text or a player or a game object. Programmers and non-programmers can use these graphs to design logic or create prototypes, to build out game logic. You can also combine visual scripting with programming. You can use either one or both together. With visual scripting, we have a graphical way to manipulate objects and their behaviors in Unity. The logic or the game flow is built by connecting nodes together. Visual scripting also has an API, Application Programming Interface, which means that programmers can use coding to unlock more advanced visual scripting tasks or create custom nodes. So if you are a programmer, you can take advantage of visual scripting and program in your own nodes or your own advanced tasks that you can build visually. But if you are not a programmer, you don't have experience with application programming interfaces, then you can just stick to what visual scripting enables by default. So how do we access visual scripting in Unreal? Well, we have to download Unity 2021 or higher, because in these versions of Unity, visual scripting is available automatically. It is embedded into the editor. If you have an earlier version of Unity, you can download visual scripting for free from the Unity Asset Store. The Asset Store is the official marketplace for adding additional tools and elements to your game, like landscapes, textures, materials, models, and plugins like visual scripting. Visual scripting is made up of graphs, which are visual representations of logic in your game. Each graph is like a file of code. We have two main types of graphs. First, a script graph. Here is where you put in the script, which you could write in code or you can build visually. A script graph is used to define what a game object should be doing while the app is running. For example, should a player be able to move? Should a player be able to rotate? Should a player be able to run around and shoot objects? With a script graph, we can control and connect specific actions and values. For example, if a player finishes a level, then go to the next level. This is an action sequence that we have to build. Actions in a script graph happen in a specific order, whatever order you specify, like every frame of the game, every second, whenever an event occurs, like when a player eats a collectible item. You can connect nodes together and use these nodes to tell your app what it should do and in what order. What should happen when the game starts? What should happen when the player gets damaged? What should happen when the player gets attacked? Another main type of graph is the state graph. A state graph tells the app when it should change its behavior, so it's slightly different from a script graph. A state graph tells the game should you change the behavior based on an event or after a condition is fulfilled, like after a minute has passed. A state refers to any set of behaviors that you want a game object to perform. Visual scripting represents states in state graphs, where a state graph contains states and provides the logic for when your game should move between states through connections called transitions. We also have script machines and state machines related to script graphs and state graphs. A script machine is a component that you put onto a game object, like a transform component or a rigid body, but in this case it's called script machine. This component lets you use a script graph in your game. You cannot use a script graph unless you attach it to a script machine, so it's like the container. A state machine is the same, but for a state graph. We have different machine types, graph and embed. A graph source type for your graph is typically used because your graph will load faster and it's easier to maintain. It can also be reused. So you can write one graph and you can reuse it on different game objects. However, if you set the graph type to embed, you cannot reuse it. Typically, you will use the embed type to refer to game objects from your current scene in the graph if you're not using your graph on a prefab or reusable object. As well, if you're only using logic once in your game, then you'll put it into an embed graph. Otherwise, you should use a graph type instead of embed type, because if you switch from embed to graph because suddenly you want to reuse a graph, well, you're going to lose the whole graph, so be careful with that. If you switch from graph to embed, however, the graph file will still exist in a separate file in the project. The core aspect of graphs are called nodes, the most basic part of creating scripts in visual scripting. A node is like a block or a rectangle in the graph editor. A node can represent an element or do a task. It can represent any programming element like an event, a function, a variable, a game object, a loop, a conditional statement, a value, and much more. Blocks or nodes can listen for events, get values of variables, or modify components on a game object, like change the position of a game object, change the rotation, and more. A node has ports or pins on its left and right sides. On the left side, the ports are the input ports, what the node takes in. On the right side of a node are output ports, what the node gives out or produces at the end of its task. Control ports control the logical flow of your graphs. They tell visual scripting what should happen one after the other. What is the order of execution? If your nodes are connected via control ports, then they'll happen from left to right along the flow of your ports. Arrows located beside the ports display the direction of the flow of logic. Other than control ports, which are for the execution order, we also have data ports, which allow you to send and receive data between ports and between nodes. So a node can send out some data to another node. As well, a node can receive data from a node. Examples are number values or game objects that you can pass between nodes. Data ports have colors that correspond to the data type, because we represent values differently if they are numbers or if they are words or more. We also have node overloads, which means a node can have multiple variations, where the input or output data can be different for a node depending on the data type. A key aspect that we already briefly mentioned are connections and ports, which connect a port from one node to a port on another node. So we can connect nodes via their ports, and this will create the logical flow of our game. So that's how we can create our flow with visual scripting. Visual scripting will highlight ports on any other nodes where you can make a valid connection, and by default will dim any nodes where there is not a valid connection that can be made. Connections are color-coded, so connections that control the logic flow or those control ports, they are white. Connections that are for values or those data ports, they have a different color based on the data type of the value. So that is an introduction to Unity visual scripting. Coming up next, we're going to cover more about what you need to know for Unity visual scripting, and then we will use visual scripting in our game project, so don't miss the next lecture. Coming up in our project, we're going to use events in our script graphs. So we have to know what is an event in Unity visual scripting. Events are commonly used in programming in general, so they're important to learn. With an event, we can enable a script to perform a series of actions in response to an event that occurs in the game. For example, an event that the game began, or an event that the level reset, or an event that the player got attacked. And we can use event nodes, which are called when the event happens. The goal being that when the event happens, we can begin execution of a network. We can do certain code logic or game logic, such as when the game begins, spawn a new player, and start the level. So we're waiting for the event to happen, and then we start a series of actions once the event has been triggered. An event can execute one object, but you can trigger multiple actions after that by stringing all the actions together via our control pins. An event is the starting point for all scripts. And an event node looks like a special green block in a Unity script graph. Two common events are start and update. Start is called once the graph or event handler is first created, and update is called at every frame while the graph or event handler is active. An event will take inputs and produce outputs. All events have a single trigger control output, which will start the script when it is triggered. As well, an event has value inputs, which are options that influence when the event is triggered. For example, some events have a target setting which determines which object is listening to the event. An event also has value outputs, which are arguments passed from the event. These are values that the event produces that give you more information about what happened. For example, the onTriggerEnter event will have a value output of the other collider that is involved in the collision. So between the current object on which the graph is connected and whatever collided with that object, we can grab what object was part of the collision. So that is an event in Unity visual scripting, which we will see shortly in our project. Join me coming up next. We're going to continue our introduction to visual scripting elements. If you liked this video, then go to training.mammothinteractive.com. We have tons more content on blockchain, web development, machine learning, and much more. We also have a membership for just $19 a month where you can get access to our 372 course bundle and counting.